So today we're going to solve two short problems as the problem of the day. Both are taken from the back of the end of the chapter for chapter 21. The first question asks us to draw a budget constraint, assuming that you pay no taxes. So although they don't say it, the focus here is going to be on leisure supply and all other goods or consumption, like we talked about in class. And then they want us on the same diagram to draw a new budget constraint to pay taxes. So we'll start off by drawing a standard consumer choice diagram. Our two goods we know are going to be consumption or all of the goods. I'll just label that C. And leisure, which I'll use Z to label. And then we have to think about the trade-off between the two. We know that the price of leisure is going to be W, and we can normalize the price of consumption to 1. But since they don't really ask us to be specific with numbers on this diagram, we can really just draw a standard budget constraint and just keep in mind that the slope is W. Now we're told that we have to pay taxes on our income. Basically that means if you work for an hour and make $10, your wage is $10 without taxes, and now you have to pay, say, 20% in taxes, your effective or your post-tax wage is now lower. So basically what that means is that we're going to have, if we work as much as possible, we're going to have less consumption, and our budget constraint is going to have a less steep slope. So we're drawing a new budget constraint showing that we have less consumption for any given number of hours of work, and now we have our budget constraint. So that's part A. Part B is really the heart of the question. It asks us to show how this tax might lead us to work more hours, fewer hours, or the same number of hours. The most intuitive case is less work, so we're going to put in less labor. But to make sure we draw the diagram right, we need to remember that L, labor, and Z, leisure, are inversely related. So when they say work less, they mean purchase more leisure. So let's draw an initial budget constraint that represents what we originally were optimizing. We'll say that that's this point here, where the indifference curve and the budget constraint are tangent. And then we'll draw in a new budget constraint, similar but below, because now we have less effective income. And we see that the new optimal point has shifted further to the right, and we get less consumption but more leisure. So that's the intuitive case. That shows how we can work fewer hours. Now we're going to move on and diagram the other two cases, whether it's the same number of hours worked or more hours worked. So to get the same number of hours worked, we're going to need the two optimal points to have the same number of leisure. We can get that by just basically replicating a precise downward shift. And these two line up. Our goal is to say that they line up so that we have the same number of hours worked, which implies that we have the same amount of leisure that we purchase or consume. The hardest case and the most counterintuitive case is where we work more hours even though we're getting paid less per hour. But we'll go ahead and draw that. Suppose that we were working very little to start with. So we had this as our budget constraint and this as our indifference curve. And the optimal point here is pretty close to having no leisure. So we were working a lot. And now because of the shift, we want to pivot. We want to have that optimal point even further to the left. So basically no leisure at all. We can get that by carefully drawing in an indifference curve like this, where we have a slight leftward shift in the amount of leisure, and thus a decrease in the amount of leisure, and thus an increase in the amount of labor supplied. So those are what the three diagrams would look like. They don't need to be, drawn particularly have like a completely straight budget constraint or have indifference curves that have exactly the same shape as you shift them around. Neither of those are necessary to the theory. You just want to convey the intuition by drawing like roughly bowed in indifference curves and roughly straight budget constraints. The second question asks us to consider a statement by economist George Stigler, who won the Nobel Prize. If consumers do not buy less of a commodity when their incomes rise, they will surely buy less when the price of the commodity rises. Explain this statement in using the concepts of income and substitution effect. So So the basic idea is we want to start by looking at the given part of the hypothesis. If consumers do not buy less when their incomes rise, and think about what this tells that about the whether the good is having positive or negative income effects. So we're told that when income goes up, so I goes up, then the quantity the person buys will either go up or stay the same. So it can't go down. This is another way of saying that it's not inferior. Because inferior by definition means that when income goes up, we need to buy less of the good. So basically all he's saying is that it's not an inferior good. So now that we know that the good's not inferior, we can think about how the quantity that we buy is going to change when we have an increase in price. So you have a price increase, and we're going to have an income effect and a substitution effect we've got to think about. The substitution effect when the price rises is always going to be negative, because if a price goes up, we're going to substitute away from that good. So this has got to be negative. And now we have to think about the income effect. When the price rose, we effectively have less money. So we're going to do, so if the good is normal, which we know it is because we've ruled out the good being inferior, then we know that we're going to buy less because our income went down. We've also left open the possibility that there's no change in Q when income changes. In that case, the income effect would be 0. So either the income effect will be 0 or it'll be negative. So by combining these two, the income effect and the substitution effect, we know that the consumer has to buy less when the price goes up. And that's exactly what Stigler concluded. So we explained his explanation by saying the total change in quantity is going to be the sum of the income and substitution effects. They're both non-positive. One of them is negative for sure, so the total change in quantity has to be negative, just like Stigler said.